We'll begin this session with Jayanta Roy, who is going to give an overview of the Spotlight system.
Thank Visweshwar. So I think today we have most of the talks in the first half is actually about a project which you are running at GMRT. It's a commensal Fast Transient Survey project. So what I'll be going to do, I'll just talk to you for a few minutes only, just to give you basic introduction of the project and all the final details and where we are standing. I'll be given by the team members. So yeah. So okay. So as you can see, actually this is like it's very recently built system. I'll just take you through the timelines. So, and as yesterday you're hearing up from the CDACs about the setting up all this national supercomputing system at various places. So this is one of that, but it is a little different than the regular supercomputing system because this is actually a purpose for a single user specific job. It's not unlike like a general purpose supercomputer, and that is the GMRT observatory system. So it's a big team effort. So it is like we have this fund from the DST and Ministry of Information and Electronics Technology, this MIT. And then there are various teams who are actually kind of putting their effort together to get the system going. So we have, starting with, we have a data center team, it was kind of developed mostly by the CDAC engineers. So they only kind of put the clusters, connected it, make sure the software stacks are everything is fine. And then we also joined because we didn't have enough experience in our place to kind of build up a data center in a very short time scale. And we had an AI team, again, we didn't have any in-house experience. We actually collaborated with the NVIDIA partners to kind of build up yesterday you had heard from the Bharat. So you are actually working together to build a CNN modules and all those things, starting with something which is already existing. And then HPC team is also there. We have people from NCRA, we'll be hearing talk from them about the system, and also people from the Oxford, from the research centers to kind of come under the India-UK partnership program. So there are a very large number of group of students, postdoc engineers who are kind of working on this. So anyway, so this slide, I'm just going to very briefly talk about what are the products out of the Spotlight. So as this is a time domain instrument, though we do a little differently than the regular time domain data crunching. So we actually try to see all those sources like pulsar, FRBs. Again, yeah, not a super fast millisecond pulsar, but something like double interrupter kind of system, long period transient magnetars. So everything will just going to pop up and then going to give us different kind of science outcomes, and including there is a recent addition which we'll be hearing next week from our collaborator in the Breakthrough Listen team to introduce SETI inside a Spotlight. Okay. Anyway, I'll not go into that. I'll just go to the timelines. So the whole project has actually got sanctioned in 2023. So and then the actual things on the ground started happening in 2024. And so we had, those who have visited GMRT, you must have seen the correlator room, because that is one of the must-go place in GMRT. And so then the correlator room inside a Faraday cage. So anything you build in the observatory, that has to be inside a Faraday cage because all these commercial instruments are actually, or commercial computers radiates, like all the CPU, RAM, every frequency, the radiation comes from there. So first thing which you have to do to build a Faraday cage, and the cage has to have 100 dB isolations, all the way from couple of kilohertz to hundreds of gigahertz. So we ensure up to tens of gigahertz, the isolation remain constant. So that is the first thing to do. So build a metal cage out of it. And then once you build a metal cage, and then you build a data center inside the metal cage. So that is the next job. So by middle of next year, I think we are done with the data center. Middle of last year, we are done with the data center. So everything happened pretty rapidly because we had the team who are kind of specialized in doing this thing. And then whole software deployment starts. So data center was kind of commissioning in the middle of June, and then all the testing, system release and software deployment started from October last year. And by December, we have first science result, in the sense like we kind of seeing the outcomes from this. So yeah, so it has happened almost in 1 year, so in 2024. And then we started doing commensal science from the May this year in offline, and also not a full system. We had to deal with some of the issues of sensitivities and like to get the actual theoretical expected sensitivity and take care of the RFI mitigation, everything, which you'll hear from the other team members. And from this last month, we are actually fully real time with a limited number of it, not the one which you are actually aiming to go. So now, but then now GMRT is maintenance, and when it will open up, we will be actually regularly searching for transients. Okay, so now this is the slides where you will be actually seeing the detailed description from the project members. So when you'll be seeing whatever blocks I have kind of encircled. So there will be a special there is a specific talk to kind of talk about that what is the status of the system, what are the challenges, what are the uniqueness of each of the components, and then definitely some of the result which people have started seeing. So I'll not go into the details of that, but as it shows, already is a kind of bit crowded block, so it requires special attention by individual talks. So I'll not take you through that. So we'll be hearing from everybody. What I'll just say that you are interested in opening up the project for anybody interested joining there, and we'll be sharing a Google form so you can express your interest to contribute in the Spotlight project, either way, either from the science or development, any aspects. So I'll stop here. I can take some questions here, but in internal details of that, maybe I'll just request the team member to answer. So yeah, I'm done.
Yeah, thanks, Jayanta. So what's the rough timeline for the 2000 beams?
Okay, yeah. So there's a timeline is uncertain. So to start with that, but maybe I'll just tell a little more than that. So currently we have 320 beams there. So you can actually form 320 beams and you can search through 320 beams in real time, including the trigger for transient, trigger for imaging and all those things. The way we are right now, the code, the way it is written, we can go up to 640 beams, okay, without this scaling. Okay. But beyond that, there needs some changes in the code. So that we haven't really, territory you haven't ventured yet. So it will be a little more, that's why I said uncertain. So it will be a little more development required in terms of enabling the more than 640 beams, or maybe more than 800 beams, and then going on to 2000 beams. So I'll just say reaching up to 40% of the thing, we may be able to do just scaling the current thing. We haven't used the full cluster yet. So we have just scaling the number of nodes, the number of compute resources. We will be able to scale all the way up to 800 beams. That is a hard limit right now we have. Anything you go beyond that, that requires a little bit of engineering on the code.
So at the moment, I guess the plan is for 320 beams then.
Yeah, so right now is that once, like in next week when the GMRT opens up, 320 beams will be running. And throughout the next few months, by the end of this year, we should have 640 beams there. And then beyond that, we'll see.
All right, thanks.
Yeah.
Thank you. And is there a kind of a roadmap on what will happen in a few years down the line? What may be the next upgrade?
Yeah, so, okay, so right now what will happen, there are a few things we are actually considering, which we can discuss more in the afternoon. So one thing we're actually thinking about that the way, so it's like, let's say, when you are stuck in 800 beams, it's already 50% of the projected space which you wanted to cover. And what is the way to do it? Either you put more compute resources to do that, or you do it differently. Okay, so there are two ways of looking at the problem. So so if you look at differently, then the way you can actually follow. So when the people will be talking about that how they are getting from the beams, you'll see that it's a little different. But the way there are examples like the way DSA is moving, on the way Krakow is moving, it is actually image domain things. Okay, and GMRT is also interferometer. So one way is changing is that we are doing a visibility domain thing. So the way to look at it is you can move from visibility to the first imaging part completely. Okay, and then at that point, if you can make that image out of it, then you will be able to increase your field of view. That means the number of beams will be possible to increase. So the one way to look at it is that now instead of doing a visibility-based beam forming, you go to the complete image domain and then do the look at the image pixels there to search for fast transients. So one way to look at it, that could be one possible growth path. Another thing will be that we just do a little bit of more compute resources, put it there, and increase the number of beam all the way from 800 to 2000. So that will be the possible growth path within the system itself. But definitely there will be something more is when you're looking outside the system. So like how you are actually kind of well connected to the network of fast transient people to kind of do a rapid follow-up and all those things.
So sorry, can I ask one? So will this feed into the UGMRT? Would this benefit the UGMRT plans, or how will they merge, or do they go parallel?
Sorry, I didn't get. So
how the UGMRT plans and not the expanded eGMRT plans?
So how you say how the GMRT is moving?
And how it will expand. That expansion will go in synergy. What is the synergy between the two?
So currently this is actually having 400 megahertz bandwidth capability, bandwidth processing capability. So if GMRT expand their bandwidth capability beyond 400 megahertz, then you need to also change, because we don't have correlator beamformer resources which can process more than 400 megahertz. So the GMRT ways also there are multiple directions how it moves. So one direction which you have proposed to increase the bandwidth from 400 megahertz to 1 gigahertz. instantaneous bandwidth. So if that happens, then this system will be actually sampling a part of the band. Okay, not be able to process at least more than 50% of the band. So that's one GMRT direction. If GMRT moves towards the expanded GMRT, then definitely this has to be expanded in that sense. So since those development has not happened yet and is just kind of either proposed or on a paper in the process of getting proposed. So right now, at least next few years. So this is funded for 3 years. So the way things goes, we have fund to run the system for 3 years. That means the running cost, which comes from the CDAC. So the electricity cost is quite high. So we are happy to run it for 3 years because we don't have to worry about the fund from the organization point of view. But beyond 3 years, then by that time GMRT growth will also be cleared. So you can see in the same time scale, we can also have a different way of looking things.
Great. I had 2 questions actually. One was on the science side, the other on the policy side. So from the science perspective, because on the slide you had, you're also going to go for long period transients. I was wondering how you do that technically, because if I got it right, you have buffers of, I don't know, tens of seconds, but long period transients, we're talking minutes, 10 minutes, hours timescales. How are we going to find those with Spotlight? Yeah.
So in a long period transient, currently the way we are moving is actually the project which we have taken to process the GMRT archive data. So the pipeline is right now running. It is a semi-automated pipeline which actually goes through 10 years of GMRT archive data, which is like a second or 2 seconds kind of resolution. So that is perfectly fine to search for long period transient. So that's what is happening in terms of the software part or in terms of current processing. Now, when you look at the Spotlight has 2 different kind of visibilities. One is that 1.3 millisecond visibility, which actually for the FRB localizations. And in addition to that, there is 1 second visibility, which is continuously getting recorded. So the LPT, which will, the search will happen is 1 second visibility, which is on disk. So you don't have to buffer it. So we'll actually just have a continuous recording of standard 1 second visibility feeds files, and LPT search will happen.
And this is being done for the full, or you just, how does it work? Do you get visibilities for each of those 2,000 beams, or is that?
So currently the LPT search which we are doing on GMRT archival data is image plane. So we actually image the full data, full field of view, and look for the single pulse in each of the pixels. So that same pipeline will be able to use it here because this is actually running from the disk. So the same thing will happen. This is a fully offline and image-based search for the LPTs.
Cool. And on the policy side of things, because this is happening in the background for all observations, right? What do the PIs do? Can the PIs opt out, or do they have to opt in, or how does that work?
Yes, sure. I think that when you people actually, some of you have proposed for GMRT observations, which is the proposal system which Visweshwar actually developed that. So there is options we have given that keeping your science interest, you have a possibility to opt out from the conventional thing. So once you opt out from the conventional thing, which is captured in our scheduling system, so because everything is automated, so then scheduling system captured that and Spotlight is not run for that time. Okay, and yeah, so that's why you give the.
All right, so in the interest of time, we have to move ahead. Thanks, Jayanta, for the overview talk and also the